It's creeping up the floorboards, got me wondering where I stand.
All right. Buenos días. Es un gran placer estar aquí esta mañana. Muchas gracias. Muchas gracias a todos. Thank you very much. It's a pleasure to be here. My name is Jeff Woolsey. I'm a Principal Program Manager in the Windows Server and Cloud Division. Thank you for coming to our session, Transform the Data Center. I know we ran a few minutes late in the keynote. Thanks for rushing on over here. To the folks in the overflow room, thank you as well. We appreciate having you here. I'd like to introduce Mr. Jeffrey Snover, one of our distinguished engineers here at Microsoft. Jeffrey?
Yeah, howdy. So I'm Jeffrey Snover, distinguished engineer, and I was the lead architect for Windows Server 2012, and that must have worked out pretty well because now I'm the lead architect for Windows Server 2012 and for the System Center Data Center products. And that's a theme you'll see throughout this session, and that is the integration of these two technologies into an integrated stack. Now, you just had a great keynote. Keynote flew, talked about all the things that we're doing. This is sort of like the data center keynote, okay? So we're not going to, after this, you're going to get all the details from all the technologies. What we're going to do is just one level down from the keynote, address some of the things, and then give you sort of an engineer's perspective, sort of why are we doing what we're doing behind some of those big level themes, okay? So, you know, it all starts with the cloud. And for Microsoft, it starts with the three clouds. And this is an area that's very different between Microsoft's stories and the other people's stories. We believe in a three-cloud approach. The first cloud is, of course, Windows Azure, running things up there. In Windows Azure, it gives you maximal flexibility and agility. You can say, hey, I'd like to have a server. You get it like that. And you say, I got it wrong. I'd like to have 1,000 servers. You get it like that. You say, actually, I got it wrong. I'd like 200 here and 200 there and 200 there. Like that. So maximal scalability, maximal agility. Then there's also the private cloud. You can run these technologies on your own machines. And when they're on your own machines, you have infinite control. You can decide, you can engineer the latency between the machines, the bandwidth between the machines. You can put the machines in a particular room with a lock on it, and you can control who accesses those machines. So in a private cloud, you have infinite control. And then you also can use service provider clouds. Service provider clouds are great. You can rent software from them, and they often provide value-added services to help you get to the cloud. Okay? And the key is that Microsoft plays in each one of these clouds, gives you the opportunity to decide which one makes sense for you, and we eliminate the costs of making a mistake. In other words, you'll see throughout the talk how you can start in one area and then move to another cloud or split things up. So that is our three-cloud strategy, all with a unified, integrated stack. We'll talk more about that. You'll like that story. So ultimately, what we're going to talk to today is drill down into this notion of transforming the data center. Now, from an architectural standpoint, I'd turn this into two very concrete things. First, get really simple. Cost and complexity, they are the enemies. They must be destroyed. And the second is that we have to solve the problem in the right way, which is to say that the abstractions need to be integrated. And I'll give you a couple examples of that. So what does that really translate to? Well, ultimately what we're trying to do is we're trying to produce a world where products are safe and easy and they just work. Okay? Which is to say, you'll want to accomplish something, you'll go, you'll find the products, you'll plug them in, and they just work without a lot of fuss, without a lot of muss, without a lot of risk. Now, how do we achieve that? Well, one of the key things we're doing to achieve that is this heavy emphasis on standards, standards-based management. And what we call this is the data center abstraction layer, or the DAL. You know, in the past, we talked about the HAL. Microsoft, in the past, you know, I don't know if you remember back then, but there used to be things like, oh, buy this version of the BIOS because it's 85% compatible with the IBM BIOS, so these products work. These don't, but these do. Just a horrible, horrible world. And so what happened was Microsoft worked with the industry to standardize a set of technologies we called the HAL, the hardware abstraction layer. And it's the reasons why you can go out and just buy a PC and it works. And it helps the Linux community as much as it helped the Windows community. Well, we're doing it again for the data center, right? The cloud, you know, there's a lot of talk about the cloud. Our vision of the cloud is very, very simple. The cloud is a cloud OS. A lot of people view the cloud as something you bolt on top of a static operating system. We reject that thinking. The cloud is a classic operating system problem. The operating system has two missions. Mission number one is to abstract hardware for consumption by multiple consumers. Mission number 2 is to provide services to applications. So when we say Cloud OS, we mean executing those 2 missions in the context of a data center. And so this is why we have the DAL, the data center abstraction layer, using standards-based management to be able to manage all the elements of the data center. And just as the HAL benefited the open source community as much as it helped Windows, so too the DAL and our support of standards-based management will help all the other cloud initiatives as well. This is truly an industry initiative. One of the differences is that we will build things on high volume components. Microsoft has always been about taking these hard computing and making it available to the masses. Our formula is really quite simple. We build excellent solutions. We use the magic of software to provide a simple experience on high volume hardware, which drives adoption, which drives volume, which lowers prices, and this is the virtuous cycle. We did it with PCs, we did it with enterprise software, and we will do it with the cloud. Now, so part of this is the ability to solve the problem in the right place in the right way. Because we have an integrated stack, we are able to decide for solving a particular problem, what layers of the stack do we need to change? And this is different from the other guys. They don't take that approach. Ultimately, this is all about creating a world where you shift your energies and your attention from planning, evaluating different things, deciding whether they work, deploying things, debugging things, to a world where you shift your resources to just buying and adding new capacity to your data centers. That's our vision of transforming the data center. Ultimately, then, this idea is expressed as cloud plug and play. How many of you ever had a CD-ROM before plug and play, CD-ROM reader? Okay, so you probably had the same experience I did. So I was at Digital, and I was a hotshot at Digital, and so I was in a position to get one of the first CD-ROM readers, and I thought, oh man, I am hot stuff. This is awesome. And so I got that thing. Oh my God, those were 2 of the worst days of my life. You had that paper clip that you bent and you're like doing the dip switches, and you had IRQs and IO maps, and oh my God, 2 days later, I thought I was the stupidest person in the world. Finally, I got it working, and then somebody comes down the hallway and it's like, hey Jeff, I heard you got a CD-ROM reader. I'm thinking of getting one. I was like, no, don't do it. Just wait. And now that's not the case, right? My boss told me the other day, he said somewhere he got a DVD for something, right? And he went to play it, and he says on his Ultrabook there's no DVD player. So like, what do I do? And so what he did was he went down to a store, might have been a local grocery store or any store, and he bought a CD-ROM reader, cost him like $40, and he just plugged it in, and what happened? He plugged it in, the system recognized it, evaluated what it was, found the appropriate software, made the appropriate software available, mounted that drive, and he was able to then just use the CD-ROM without all the details. Okay? And so that's what we want to do. We want to have a cloud plug and play. And we have 3 cloud plug and play visions. The first one is we want to be able to plug devices into the cloud and have them just work anywhere, anytime. That your devices, whether they're PCs, laptops, phones, tablets, ours, other people's, you plug them into our clouds and you'll be able to access your data, your people, and your applications. And this cloud plug and play just dramatically simplifies the lives of our users. The next is to plug applications into the cloud, and they just work. Now, these applications can be Windows applications or Linux applications. Yeah, put your seatbelts on. We're going to show you and talk to you a lot about our great support for Linux application. Who would have thought? But it's true. And when we say plug them into the cloud, you'll be able to take these applications and plug them into your private cloud, service provider cloud, or Azure cloud, and they're just going to work. So it dramatically simplifies all that work around developing and deploying applications. And lastly, we have the idea of being able to plug any resource into a cloud. And by resource, I mean servers, raw servers, top-of-rack switches, storage devices, and have them just work. And this simplifies the process of creating a cloud fabric and managing that cloud fabric. So ultimately, this is what Microsoft does. We take the stuff that's really hard. Anybody think cloud computing is simple, easy today? Yeah, no hands. Right, it is hard. We will make it easy. We've done it before, we'll do it again. And just to be clear, this is a journey that we won't get there in one release or two releases. This will take time. But honestly, in this release, you'll see we made some fantastic progress. So I look forward to talking to you about that.
Awesome. Very much so. And it is a journey. And one of the things we want to point out, though, is it's time to get on that journey right now. It's time to virtualize literally every workload. You know, starting with Server 2012, we massively amped up the scale in terms of Hyper-V. Quite simply, I don't know of a workload we can't virtualize anymore. And if you just came out of the keynote, you just saw that we just dramatically upped performance again from a storage perspective, from a live migration perspective. It's time to virtualize every workload. It's time to rethink storage. Honestly, I talk to customers, and every customer I talk to, let me say this with unequivocal 100%, every customer I talk to has a storage problem. It costs too much. I have too much of it by different manufacturers, so it's all over the place and it's siloed, and I don't have enough. And usually the answer is all three. Every customer has a storage problem. It's time to rethink storage. It's time to simplify networking. If you want to move to the cloud, let me tell you something. VLANs just were not designed to do what we're doing these days. VLANs were great 20 years ago when we had, we had the production network and the test dev network. Now I talk to customers all the time. I was in Australia last year and I spoke to 12 customers and I asked all 12 of them the same question. How many VLANs do you have in your infrastructure? 11 of them said hundreds. The 12th one couldn't tell me if it was hundreds or thousands. I said, how do you manage these? Spreadsheet, of course. It's a disaster.
And a rabbit's foot.
And a rabbit's foot. It's time to simplify networking. Just to give you an idea, on an average day, Azure, we make over 50,000 network changes a day. Do you honestly think humans make those changes? Not a chance. We define policy, we define the fabric, and we let the fabric do the rest. So when I talk about being able to virtualize every workload, let me give you two fantastic examples we just announced today. World record, Windows Server 2012 Hyper-V. Windows Server 2012 Hyper-V. SAP came out last year that we actually spent a ton of time testing Windows Server 2012. I met with their architects many times, and we told them straight out, what is it you need to make Hyper-V, make SAP run like a champ, run like a charm, run like a Ferrari on top of Hyper-V? They gave us their requirements, and then we said, great, we're going to go exceed every one of those requirements, which is exactly what we did, which is exactly why you're seeing this world record performance trouncing the other guys using Server 2012 Hyper-V. And in R2, it's even getting faster. In addition, the other huge bombshell, Microsoft and Oracle partnership. Oracle supported on Windows Server and Hyper-V and in Windows Azure. This is also a good point to remind everyone, what do you think Windows Azure is running? It's Windows Server, Server 2012, Hyper-V. The same bits that you get in Server Hyper-V, that's exactly what we're deploying in Azure. Azure is literally running hundreds of thousands of servers, all Hyper-V, 100% Hyper-V for all of our compute nodes. I cannot be more explicit than this. Hyper-V is powering the world right now. Most of you don't even realize it. Has been for years. Now what this Oracle partnership means is you're talking about now license mobility for Azure. Java, fully supported in Windows Azure. Oracle, now supported today. Mark Hurd himself said this is immediately. Oracle is supported on Windows Server Hyper-V and Azure. This is exactly what our enterprise customers are looking for. They're looking for this partnership, this support. You want enterprise best, it's right here. So, we delivered like gangbusters in Server 2012 R2. Quite simply, we're pulling ahead even farther now in 2012 R2. What did you tell us? You told us, Jeff, we want to reduce complexity, cost, downtime. Help provide easier deployment and support lifecycle workloads. Provide flexible virtualization platform for agility. We heard you loud and clear. What are we delivering? Here's just a few of the things. Cross-version live migration. So if you've already deployed Server 2012 and you're hearing about R2 and you're going, hold it, I just deployed 2012 Hyper-V, no problem. We made it real easy. You can take those virtual machines running on 2012 Hyper-V, drag and drop them and they will live migrate to 2012 R2. Made it really easy for you to upgrade. We now provide online virtual disk resize. While the virtual machine is running, you can go hot dynamically change the size of the VM. And it's not just grow, it's shrink too. So you get them both. We also have things like live VM export cloning, remote access via VM bus, automatic VM activation. This is really cool, especially if you're a service provider. Are there any service providers in the house? Any cloud hosters? Okay. You guys and large enterprises, you're going to love this feature. Because now if you deploy Windows Server 2012 R2 Data Center Edition, we will automatically activate the guests for you. This is actually really important for a service provider because very often you're running on 2 different network domains. Now you don't even have to worry about that because it will look down and the guests will automatically activate if you're running Server 2012 R2 in the guests as well. We also have, like I just demonstrated in the keynote, live migration compression. On average, it's at least 2x faster than it was in 2012, and in many times even 3 and as high as 4 and 5x faster. And then RDMA, honestly, it's mind-blowingly fast. You saw that in the keynote. We went from 1 minute and 20 to 10 seconds. You will not find a faster live migration in the industry.
By the way, so you remember I talked about how we want to solve the right problem in the right way, the right layer of the stack. We did the deep foundational work for this in Windows Server 2012 with the RDMA in the kernel and getting SMB to run over RDMA. So we had fantastic performance for RDMA. And then here, having solved that in the right way, we're now able to take live migration and put it on it and get this incredible benefit. This is an example of solving things in the right place in the stack and getting, just semantics and capabilities that the other guys are not going to be able to do.
Exactly, exactly. And there's plenty more. Those are just a few of the top line capabilities. Then it's about changing the game in storage. We're about providing maximum performance, scalability, and resiliency, but with minimum costs. This to me is magical. SSD. I feel like I've been waiting for this like half my life. I remember pulling out my hard disk. I just found this in my garage a few months ago. My old 20 megabyte hard disk from my Atari ST. Okay, it's about the size of a shoebox. I remember bringing it home and having my mom scream at me in Spanish. My mom was from Panama. And my mom was screaming at me in Spanish, wanting to know why I spent $700 on something with a little blinky light on it, and she had no idea what it did. And I look at that now, and I laugh because keep in mind that for the last 50 years, hard disks have had rotating media, spinning platter with a little read-write head across them. SSD is changing the economies of storage in a very big way. Now we're talking about fantastic IOPS performance that we want to leverage and solve those hard problems, as Jeffrey mentioned earlier, in software. So we want to provide resilient storage, better control, maximization of utilization rates of your storage investments. We want to demystify the storage appliance. So let me explain this for just a minute. So one of the things, I mentioned Spaces in the keynote, and I mentioned the file server, but a lot of people are confused about what Spaces is. So let me explain it to you really quickly. So what's a modern storage appliance? If you go out and you buy a modern NAS or a SAN device, what is it? Actually, I mean literally, if you crack open a storage head, what will you find inside? You'll find it has a couple of x86, x64 procs. It's got memory. It's got network adapters. It has storage HBAs. That sounds awfully familiar, doesn't it? That sounds awfully a lot like a server, if you ask me. Well, let's take a deeper dive. What's in that storage head? Well, if you take that storage head and logically divide it in half, there's a back and there's a front. What's the back? The back is basically these HBAs, and they're usually SAS connectors. This is where you provide multiple physical interfaces. This is where you pool disks, you present LUNs, you do simple mirroring, parity, etc. This is what plugs into your disks, and this is usually over a SAS interconnect. Then the front part of your storage device, you present interfaces, iSCSI, fiber channel over Ethernet, NFS, SMB. Of course, they never sell you one of these. They always sell you two. And the reason why is because this gives you a scale-out solution. It also means that if the first one goes down, that the second one continues right along without any interruption. So that's why you buy a scale-out storage solution. Again, and it's usually they sell you in two increments. Of course, now you plug in your servers. And you can plug into them either Ethernet, gigabit, or 10 gigabit over fiber channel, 1, 2, 4, 8, or 16 gigabit fiber channel. That's what a modern storage appliance looks like.
Yeah, can I give them a backstory on
Go
this?
right ahead.
So at Microsoft, we're passionate around, hey, where are all the Intel servers going? And we track that. And I don't know if you know this, but 75% of all Intel servers end up with Windows Server on it, right? And so we're always tracking, well, where do these go? Well, at some point, we figured out that we couldn't tell where a certain percentage of the Intel servers were going. So obviously, our data collection was off. And so we went and we investigated it, and we found out that all the storage area network device guys were buying Intel chips now. I thought, well, that's interesting. What's going on here? And it turned out at some point, Intel had made some progress in their I/O handles, so it became a fantastic CPU for storage area, for storage management. So now, when we looked at it, all these storage area devices, I mean, these used to be specialized, equipment. Now they're just generic servers.
No, they have a really big, expensive price tag on the front, though.
Oh yes, there's that.
Don't say generic. So that's what a modern storage appliance looks like. So let me show you what our file server looks like. So if you look at our file server, well, what's the back end? The back end, that's what Spaces is. Take it in for just a moment. I bring this up because I get asked about Spaces all the time. People say, can I set up a space between, Redmond and Seattle? And that tells me immediately they don't understand what Spaces are. That's what Spaces is. That's what's actually pooling all of those physical disks, presenting your LUN, simple mirrored, etc. And by the way, that's where we're doing the automated storage tiering that I just demonstrated in the keynote, right there in Spaces. So what's the front end? The front end is the file server. And guess what? That's where we deliver iSCSI, NFS, SMB. And by the way, that can be over SMB3 Ethernet, gigabit or 10 gigabit, or 40 gigabit, or even 56 gigabit. If you're scratching your head and going, hold it, Jeff, that's a lot faster than fiber channel, the answer is you're right, at a fraction of the cost. This is where we're making huge investments. We made huge investments in 2012, and we're doubling down and making even bigger investments in 2012 R2. Because you've told us quite simply, storage is way too difficult, it's way too complex, it costs too much, and I don't have enough. We want to help solve that problem. So storage tiering is about improving that storage cost performance, and again, taking advantage of the changes in the industry. SSD now, we're talking a couple $100 now for crazy performance. A standard SSD now gets me 50,000 IOPS. That's $200. To get this just, 5-10 years ago, you're talking racks of storage, racks of disks. Now you're talking about this in SSD. So we want to provide storage tiering as well as pinning, where you can actually place high priority files and just leave them running in the tier at all times. So with that in mind, I'd like to invite Matt McSpirit up here to talk about and demonstrate our storage agility and performance. Matt?
Thank you, sir.
Yeah, by the way, so
Thank you.
give it up for Matt. So as you watch Matt's think through boy, what does it take for me to set up one of these events? And how can Microsoft simplify that back to that cloud plug and play?
Exactly. So we've heard this morning in the keynote, and Jeff and Jeffrey have given us a bit more insight into the phenomenal work we've done in Windows Server 2012 and going forward in R2 around storage. It's helping you to lower costs, decrease the complexity, increase performance and resiliency. And in this demo, I want to show you how I can start to create and manage this new storage infrastructure right from within System Center. So what we have on the screen here is System Center 2012 R2 Virtual Machine Manager, and I'm in my Fabric view currently. And my Fabric view gives me a view into my servers, so my compute layer where I'm managing my Hyper-V hosts, and also my vSphere and Zen server hosts if I've got those. I can see my networking view and also storage. Networking we're going to cover later, but if we zoom in on storage specifically, what I want to do and walk through is creating a new scale-out or clustered file server. Now, the file server cluster or scale-out file server effectively allows us to provide a resilient storage platform for running our key mission-critical workloads. So the first thing I need to do is give it a name. So we'll call this scale-out file server 2, and the name can't be the same, so that's a key point. When you're building this out, you can't use the same name. That was intentional. We'll go next. And now I've got my first question that the system is asking me. Do I have some Windows Server 2012 R2 machines provisioned somewhere that I can turn into a cluster node to provide my file services? Because if I do, I'd select that here. But what if I've just got some bare metal servers that are racked connected to the network, connected to some shared JBOD storage that I can transform into a file server cluster or a scale-out file server. Because that's the choice I'm going to take. I'm going to choose this option. I've got a file server profile that contains the configuration that's going to be applied to these file servers or new file servers. And that file server profile not only contains the configuration items and information, but it also contains a virtual disk stored in VMM's library that it will deploy across the network and lay down on that physical server's hard disk. So we'll perform a boot from virtual disk, bring that machine up and configure it appropriately, all automatically. So we'll go next. I need to provide a baseboard management controller account that's got the appropriate permissions to connect to that particular machine and wake it up and deploy the particular file server operating system in this case. And I've got multiple protocols that I can use to communicate out of band with this machine. So I'll go next. And now I need to do a discovery. I need to find these blank physical servers. Now I'm going to choose an IP range, in this case, of 192.168.1.141. And I'm going to do a quick copy, and paste to 142. So I'm just searching for my range. And it'll go away and it'll discover those two servers within that range. And I'll tick both. And notice I'm skipping something we call deep discovery. Now, deep discovery, it's going to take a little bit longer, so I'm skipping it in this demonstration. But what that would do is VMM would wake that server up, boot it into WinPE, capture some important information about those particular servers, and it would display it in this next screen. So you'll see we've got CPU, core count, memory information missing. We don't necessarily need that to proceed, but that's what that particular deep discovery would give us. So I'll give this a name, file server 1. I'll give this a name, file server 2. I'll go next, and we're at the end of the wizard. And as soon as I click finish, VMM is going to orchestrate the deployment of the OS to those physical servers. It's going to connect, it's going to provision and orchestrate the installation of the right roles, the file services roles. It's going to create the file server cluster, and it's going to present that back to VMM to enable us to start to utilize that storage. Phenomenally easy, simple, low complexity, and best of all, this view script button for Jeffrey gives us the PowerShell that we can use to do that in a standardized way as well. Ooh. Awesome stuff. Now, because that would take a little bit of time, I've got one that I've prepared earlier. Here's our scale-out file server. And there's currently 2 file shares that we're using as part of that we've already provisioned. But this is a scale-out file server. So how do I scale out? Well, there's 2 ways. Number 1, I may want to scale out the compute element of our file server cluster, add more nodes to handle more demand in the infrastructure. And to do that, by clicking Properties, Cluster Nodes, I can very easily add an extra node to my environment. So I can scale that out. But what if I need more capacity? What if I've got an increased demand for more disks? Then I can manage my pools that Jeff pointed out earlier. And these pools, you'll see in this example, has got 6 disks. It's got a classification that we've defined as Tier 1, but we could have called this Platinum or Gold or whatever we wanted to name it that's relevant to our environment. And it's currently healthy, but we want to extend this out. So I'll go Edit. I'll tick an extra couple of disks that have been installed in our JBOD or in our shelf. And in this case, I want to draw your attention to this thin provisioning alert, because that's incredibly important. If we're thin provisioning spaces to be used by applications and workloads, and we're starting to fill up those spaces, I want to know if I'm starting to use and reach the actual physical capacity of the underlying storage. So that alert is very, very important. And the great thing is, if you're using System Center, you're using Ops Manager, you're going to get that alert piped up with all of your other alerts about your environment as well, in a central place. So very, very important. So we've provisioned our file server, we've extended out the capacity. Now I need to actually make some file shares available for our key workloads. In this case, our virtual machines running on our Hyper-V hosts. And to do that, there's a quick wizard called Create File Share. I'll select my appropriate scale-out file server. I'll give my file share a name. This one's going to be used by the dev team, so I'm going to call this one dev. I'm going to choose a classification to make sure it's running on the right set of disks at the back end. I'm going to give it a size, give it 20 gig, and we'll create. And that's going to create pretty quickly. So we're going to provision that new file share on that particular scale-out file server, so it's resilient. Anything we put on there is going to be resilient. And now very quickly, if I go to my tenant view and select one of my Hyper-V hosts, I'm going to right-click, look at the properties, And we can see how easy it is in the storage view to simply add a new file share. Now, it may be that it takes a few minutes for that one to come through, so it's not quite come through just yet, but I would select that file share, apply, and VMM would handle all of the ACLing and the presentation of that particular file share to that Hyper-V host. Easy stuff, phenomenal innovation that's gone into VMM, all managed centrally from one place. So awesome, awesome stuff. So back to you guys.
Great. Thanks, Matt. So if you think about what Matt showed you, I mean, if anyone's ever tried to do this by hand, you realize what he showed you is a dramatic simplification. And it really brings us towards that cloud plug and play. He showed you taking raw machines and plugging them in, being able to discover them, provision them, and then deploy the system, scale out the servers, scale out the storage, all using an integrated Windows Server and System Center stack. So this world of cloud plug and play really is bearing fruit. And again, as Jeff mentioned, what you're getting is world-class performance on commodity components with a simplified experience. If you are not rethinking your storage strategy, you should stop all your other projects and go take a look at Windows storage. Really, that's where you should be spending your time. Okay, so let's talk about networking. Next step up from storage is networking. Okay. Sorry? Oh, I'm lost.
There you go.
There we go. Our focus in on networking is, again, the same thing. It's this cloud plug and play. We want to give you a simple experience. I talked about our 3 clouds. In order to make these 3 clouds work, in order to make any one of the 3 clouds work, you need network virtualization. But if you want to have the agility of the 3 clouds, the ability to say, hey, I'd like to start off here and move there, or split my workload between here and there, you really need network virtualization. And that's the focus of our efforts on network virtualization. They are not, how do I take a bunch of Windows guys and turn them into networking experts? No, 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 no. In the same way that cloud, regular plug and play, there's lots of complicated technology underneath it. You know, bus enumerations and GUIDs and matching tables, etc. So too, what we want to do, and all that works underneath the covers, and you get this nice experience, that is our goal for network virtualization. We do all the hard work so that you don't have to see it, that you get all the benefits of the agility, the performance, the streamline with a nice simple experience. And with that, I'm going to bring back Matt, who's going to show you how he does that virtual networking across the clouds.
Thanks again. So we're back in VMM. Now, networking can be pretty complex, as Jeff highlighted before. Lots of VLANs, lots of ports, lots of switches, top-of-rack switches, aggregation switches, lots of configuration, possibilities of misconfiguration, which can result in outages, and a lot of time-consuming management. And we want to simplify that physical network. We want to simplify it through the use of network virtualization. And network virtualization effectively allows me to create, on top of a simplified physical network, these isolated VM networks that can contain our workloads, our key applications and services. They could contain entire customers if you're thinking about this from a service provider perspective. Now, what we have on the screen here to begin with is a view back in Virtual Machine Manager, and we're actually in the VMs and services view, and we're looking at the virtual networks, or VM networks in this case. And I want to talk you through how I've created some, but let's have a look at ones we've created already. You'll see there's a sales VM network and a marketing VM network. So I've created these in advance. They've got 2 subnets, one each. One's on the 10.10 and one's on the 172. So any VMs that reside in those respective networks are completely isolated from one another at this stage. No need for me to use VLANs, and it doesn't matter where those VMs within those networks reside in our physical infrastructure. They're going to be isolated, but they'll be able to communicate with each other within the same VM network. So let's create one quickly. I'm going to right-click VM Networks and create, and I need to give it a name. Now, we created a dev file share before, so I'm going to create a dev network for the guys as well. So when they're deploying these new test applications and workloads into our cloud environment, they're in an isolated environment so they can't cause too much trouble. And I need to select a physical network or an underlying logical network that this VM network is going to sit on top of. And I'm going to choose my tenant provider IPs network in this case. Now we make a decision. Do I want no isolation? So the VM network effectively sits on the physical network, so that's kind of the same way it is today. Or do I want to isolate the VMs using network virtualization? And this is where the magic happens. So this is where Hyper-V and System Center are going to come together and isolate this workload using network virtualization. And you'll see we have support for both IPv4 and IPv6 in this environment. So I'm going to go next. I'm going to define my subnet. So I'm going to call this dev LAN. And I'm going to create the subnet, coincidentally, exactly the same as the sales subnet that we saw earlier. So 10.10.10 with 24, and the same in the Create VM Network wizard here as well. Oops, no, I don't want to do that. We'll go next. And now this is new, and this is important, because now that I've defined my VM network, I need to make sure, because by default, network virtualization provides isolation for any VMs that reside in that network. What if that VM needs to communicate with Jeff's laptop that's on the regular network? Does Jeff's laptop talk network virtualization? No. So we need a bridge to enable these devices to communicate between a VM that's encased within this network virtualized world and a regular device, or a VM that's residing in a service provider's infrastructure and something that's on your premises. We need that bridge, and that bridge is the gateway. An inbox in Windows Server 2012 R2 is a production-ready, scalable, multi-tenanted, site-to-site VPN gateway that you can take advantage of to provide that exact functionality. So what we see here, I'm going to connect to a particular gateway. I'm going to use NAT. I can see my different gateways here. So this is the inbox one, but there are partner offerings as well, which the guys will discuss shortly when we go forward. I'm going to go next. I'm not going to change any of the NAT settings for now, and I'm going to finish there. And that's going to go ahead, and that's going to go ahead and create my new dev network. And I would create a nice IP pool, and when any virtual machines are deployed into that, they're isolated, they can communicate out through the gateway, and it's secure without the need to use any VLANs. All of my configuration is handled through VMM. So that gateway is very, very important. How can we help you provision those gateways more effectively in a standardized way? What we can do is within Virtual Machine Manager, in the library, we have a service template that's specifically designed for that gateway. And if I open it up in the designer, so we can see just what makes it up, you'll see that this service template is a single tiered service template with a couple of NICs. So whenever we deploy new services, new gateway services, they're standardized and they're consistent. And if I drill in to this particular service template and I look at the OS configuration within VMM, you'll see all of the settings are all predefined for me. The admin password, so it's standardized. The roles and features that need to be enabled to turn this Windows OS into a gateway. All of it is pre-configured, ready to go as a template, so I can just streamline the deployment time and time again. So really straightforward stuff. It's phenomenally powerful, and it's changing the way we're delivering networks. It's simplified, it's inbox in VMM and Hyper-V, and it's available for you to use as part of this software. So phenomenal. Thanks, guys.
Thanks, Matt.
Awesome. Thanks, Matt.
So that's yet another example where we take the integration of the base capabilities in Windows Server, match them with the capabilities of System Center to dramatically simplify the experience for you.
And what's great is we're building on top of the momentum we introduced in Server 2012. We've had network virtualization in the box since Server 2012. The control plane lives up in System Center. The data plane lives in Windows Server. I've been asked this a lot over the last 12 months. People saying, well, what do I need to buy to do network virtualization? Because, you know, the other guys tell me I need something else. Well, no, this is all built in. This is all built into the platform, and now in 2012 R2, we're making it even easier by providing the multi-tenant gateway. On top of that, we've got a bunch of things happening with our partners in this ecosystem. F5, Iron Networks, Huawei, they sound a little familiar. Well, they're also developing gateway appliances as well. Arista has developed an OMI-based top-of-rack switch. Why is this important? Think about this for just a second. What you saw Matt demonstrate was he provisioned a scale-out file server from scratch. He provisioned network virtualization and logical networks from scratch. Keep in mind that VMM can already deploy Hyper-V compute nodes from scratch. I could literally roll in a rack of servers from VMM, boot them up from nothing using just the baseboard management controller, install the OS, install Hyper-V, enable clustering without ever touching the box. So that's compute, that's storage, and that's logical networking. With OMI, now we're actually able to configure your top-of-rack switches as well. So we're very excited about these things that are happening. We're seeing more and more people plugging into this. In addition, we have the Hyper-V extensible switch. Our Hyper-V extensible switch already has support from Cisco, NEC, Five9, Inmon, and more coming that are plugging into our open and extensible switch. Finally, we have chipset extensions, so NVGRE. The way we do network virtualization is an industry standard. It's not something Microsoft proprietary. It's been around for quite a while. NVGRE, Brocade, Emulex, Mellanox, Broadcom, Intel, they're all building acceleration for that into their chipsets.
And I want to point out in the Windows Server 2012 R2, for the first time, we are now extending the Windows logo program to include top-of-rack switches. So if you want to future-proof your data center, make sure you buy top-of-rack switches that have the Windows logos. Those are the ones that are going to deeply integrate in with the Microsoft stack.
Yep. So in addition, we've also been doing a number of things around business continuity. So you may have high-end DR systems for your most critical workloads, and I've talked to a number of folks that say, why should I be interested in Replica? I've already deployed this DR system. It cost me 5, 6 digits. I've got this huge synchronous replication thing. Do I need Replica? And my answer is always this. Well, stop for just a moment. When you deployed that DR solution, are you happy with it? Like, is it giving you all of the coverage that you'd want? And almost always the answer is no. Well, tell me why. Well, I'd like to actually cover more of my infrastructure. I'd actually like to be able to provide more coverage for all my servers, but I couldn't. Because A, I couldn't afford more, or the replication requirements were more, or I didn't have enough to buy more for money for the SANs, et cetera. Well, with Replica, we can expand that usage and get more and protect more of your infrastructure. We want to broaden that coverage of business continuity as well as providing, again, hybrid solutions. So one of the things that we introduced in Server 2012 was Hyper-V Replica. And you had a couple of major asks in Replica. I talked about one of those in the keynote just a little while ago, which is a Hyper-V Recovery Manager. People say, look, I want to be able to manage my replication across multiple sites. And you know what? I love the fact that Replica is easy to use. Make this easy to use. If you're going to tell me I have to install some huge monolithic complex management thing and care and feeding for it, I want this to be easy. That's what I love about Replica. So that's exactly what we did with Hyper-V Recovery Manager. There is literally nothing to install because it's waiting for you in the cloud. And like I mentioned earlier, let me say this again, as you can see, the replication channel is actually still between your sites. All right? Replication is site to site. Azure Hyper-V Recovery Manager is just managing and orchestrating the replication. So we've done some huge work there. The other thing you asked about was, in terms of Replica very specifically, is you wanted some key capabilities, such as being able to configure the replication times and tertiary site support. So with that, in fact, let me do this one. Let me show you a couple of things that we've done in terms of business continuity. So the first thing I'm going to do is I'm going to head on over here. I've got a SQL Server running. And I'm actually going to go on and check some of the settings for this VM. So here I've got my database store. And in fact, when I provision this database store, let's inspect it right now, it's a 200 gigabyte disk. And I realized something later, you know what, this is actually going to need more space than 200 gigabytes. So what I'd really like to be able to do is I'd like to be able to change the size of that disk, even though it's running right now. So no problem. In 2012 R2, I'm going to go in here, I'm going to expand the disk, and while it's 200, you know what, let's make it 500. No problem. Literally click Next, Finish, and I'm done. And it will automatically hot expand the virtual disk while the VM is running. I can also shrink it as well. So again, this is hot resize of virtual disks while the VM is running. Another key thing that you asked about was replication itself. So for example, here I've got a VM, and let's go walk through here and let's enable replication. So I'm going to go ahead here, and let's replicate this on over to Blue 5. Click Next. All right. I don't need the page file. Thank you very much. And you'll notice in 2012, there was one setting. We always replicate every 5 minutes. But a number of people told us we want this to be configurable. For example, we found out, in fact, even at Microsoft, we have folks all over Microsoft using Replica. We actually are replicating VMs across site to different labs, across different sites, and many times it's actually across the city. We're going from Redmond into Seattle, all over the place, and folks love it if they've got, on their campus. So because of that, we can now replicate all the way down to 30 seconds. So now you want to be able to do this. This is near synchronous replication all in the box. At the same time, we've also spoken to people that are kind of living out in parts unknown. For example, there are places where they have literally satellite coverage. The networks are pretty dodgy. The networks can go down, there's terrible latency, and they want it to be a little bit more forgiving. So give us every 15 minutes. So we've done both of those settings. All of that's included here. So I'm going to go ahead, and in fact, let's go with 30 seconds. Let's click Next. And let's go here. I'm going to keep all of the defaults and click Finish. And just like that, I'm beginning my replication. So very similar to before, except configurable. However, one of the interesting things what happened in Server 2012 is we told our service provider partners, this is an awesome opportunity. There are plenty of customers that don't have a second site to replicate to, and if you're a service provider, this is a primary fantastic business opportunity for you to be that secondary site to replicate to. And the service provider said, yeah, that's great, except one problem. We don't want to have to pay for an expensive replication solution as well. We want to be able to use replication, so we actually need what we call tertiary replication. I need to be able to do another hop. So guess what? That's exactly what I'm going to do. So here's that virtual machine that's being replicated. Now I go on over here, and now I can extend that replication. So this allows me to now take it a further hop. So now I go 1, 2, and 3 hops with tertiary replication. So all of these capabilities built right into Server 2012 R2. All right. So that,
thanks.
Pass it back on over to you, Jeffrey.
What Jeff showed you, I got to tell you, is one of the most exciting and compelling use cases for the cloud. Look, everybody in this room can afford to buy a few extra disks to ensure better reliability and continuity of their data. And a number of you can afford to buy a few extra servers. But how many of you can afford to stand up different data centers at different parts of the world to ensure reliability, right? Very, very few people. And that's the great thing about the cloud, right? The cloud has your back. This architecture allows you to say, hey, I'm running things here, but then I can replicate things to other parts of the world and get fantastic reliability with resources that you couldn't afford to stand up. So that's really quite exciting. Now, again, we've talked a lot about this 3-cloud vision. And the nice thing about the 3-cloud vision is that it drives, vision, drives architecture, drives features. So as we thought about this 3-cloud vision, we said, well, okay, this is all great technology, but how are people going to interact with the 3 clouds, right? And we realized that people are going to want to be able to access and manage their VMs, their service bus, their websites in a consistent way, and to have a standardized gallery of virtual machines. And so that's what the Windows Azure pack is, right? And what this is was we took the Windows Azure code that we were doing this in the cloud, and we took that code and now we have it running for both service provider clouds and for private clouds. Exact same code base to provide this consistent experience. And I got to tell you, that's what's so neat is you start off with these visions. These visions aren't just marketing stuff. I mean, they are, right? They're marketing stuff. They're fluff. But we then take it. They hand it to guys like me, and then we say, okay, well, if that was true, here's what we'd have to go do. And then we go do it. And that's what's so exciting. And we made some great progress on that. And with that, let me bring up Mike Leeworthy to show you that. This is exciting. Now, this is the Windows Azure pack running on-premise, on a private cloud. How many people are using Azure today? Okay, great. So you'll know this experience.
Great. So you saw Claire show this in the keynote, and I love the Windows Azure pack, even though it might be a little bit of marketing fluff.
Well, now it's
One of
real.
the great things, I think it provides two phenomenal things. One, it provides your customers or your users phenomenal self-service solutions for things like IaaS on-premise or PaaS on-premise. The ability for you to provide this great self-service experience. The second thing it provides is great operational efficiency, utilizing your investments in Windows Server and System Center to really provide those great experiences for those end users or customers. And I want to show you some of the great things that Claire showed you today, walk a little deeper in that, and then show you the other side. What does it look like from the service administrator or, your administrators in your organization? How can you take advantage of this? So the first thing we're looking at here is the environment that we showed this morning. You can see it's very Azure-like. We took our investments in Azure, we really integrated those into our on-premise System Center and Windows Server environments. So I have that high-density website solutions. We can run those thousands of websites on those single server infrastructure. And the great thing here is I can create simple websites straight out of the box, but I also integrate a gallery of both open source environments and shared source environments, and also my own templates as well. So it's easy for my customers or for my users to deploy pre-configured websites in their environments in minutes, and in some cases, in seconds. The other things as well, out of the box, I've got these virtual machines that allow me to provide individual virtual machines, and also, as we talked about before, the single instance or the single tier multi-instance virtual machine role. The great thing here, it allows me to take operation system settings and operating system settings and then application settings and create them into a service tier. So when I deploy these, I basically deploy and configure that operating system and the application at the time of deployment. So I can scale these up as the way my administrators want to. So from an end user perspective, I basically choose from a gallery of items exactly what I want. In this case, we have a number of items out of the box, including our most common workloads, Active Directory, SharePoint, SQL, Windows Server. And these can be pre-configured by my service administrators or my administrators in my organization. And so my end users can then just deploy these based on their configuration needs at the time. They don't have to worry about how much memory gets associated with it, what the actual settings are to get these done. They basically then deploy their own customized settings. And then I can extend this with great new technologies in R2, such as our desired state configuration. So for example, I could take this IIS template and deploy a common IIS tier for my development organization. Then I can take my exact configurations I need for that IIS server and deploy that on top at the click of a button and do things like drift control support and other great technologies. So this is phenomenal solutions out of the box for these self-service IaaS on-premise solutions and our PaaS solutions. But I want to show you the back end of this. How do you make this available to your customers or users in your organization? So you can see this is my administrative portal that my admins will use. Again, looks and has that same familiar view and usage as we have in Azure. But you can see here that I'm looking at things such as website clouds, virtual machine clouds. So you can see here are all my IIS servers. When I look at all the roles here, you can see here are all the servers in my organization that I've deployed to support that high-density websites. If I look at my virtual machine environment, you can see this is Virtual Machine Manager actually deploying this. Here are the clouds that I've set up for my Virtual Machine Manager environment and then publish those into my Windows Azure Pack environment. Now, how do I make this available to my customers, though? We make this available through things such as plans. So for me to create such a plan for my HR department or my dev department, it's actually about 15 clicks. Let me show you. So I'm going to create a new plan here and say we'll call this plan HR. You then determine exactly what you're going to provide. Maybe I just want to provide virtual machine clouds at this stage, but you can see I can provide websites, SQL servers, and even MySQL server. And effectively, I get a summary, I click a button, and the skeleton of that plan is created. Now, if I just go and quickly click on this, I can then go and configure the exact capacity for this plan. I'm going to point it out to an existing virtual machine management server here, and then I'm going to choose one of the clouds based on my tiering. And this could be some of the tiering that Matt showed you before around storage or networking support. In this case, I'm going to choose my gold cloud. And then you can see here, I can then carve up that cloud capacity even more for the exact need of that environment. So I can say, you know what, for this environment, you only really need up to 10 virtual machines, and I'll give you, 50 cores associated with that. Basically, I save that, publish that, and that plan is available for anybody in that HR environment to subscribe to, and then go and configure their environments and provide that self-service capability and IaaS solutions on top of it. So Windows Azure Pack really provides those phenomenal solutions for you to increase your operational efficiency, built on the investments you have today in Windows Server and System Center, and really provide you that great on-premise solutions for IaaS and PaaS for your customers or users in your organization. Thank you.
Okay, thanks, Michael.
Thanks, Michael.
You know, we made a transition in the talk, and I realized I didn't point out the transition. The first few demos were showing you all about the great integration between Windows Server and System Center. And these last two demos, what we started, we made a transition, and we're showing you the integration between Windows Server, System Center, and now Azure, and how this integration provides you great power, flexibility at dramatically simplified way. And with that, put your seatbelts on.
Awesome. Thank you, Jeffrey. Yes, when it comes to unified application management, one of the things we want to be very clear about is all of the things that you've learned over the years in terms of systems management, whether it's System Center, all of those things, this still is the center of our management world here. Think about it, whether you're managing Exchange, Link, your web servers, compute, storage, networking, System Center is the way you're doing it. Think about, again, what you saw Matt doing. You saw him deploying storage, the scale-out file server, networking. We talked about being able to manage top-of-rack switches, being able to deploy your compute nodes, all of that from System Center. At the same time, we're also doing a whole bunch more. We've always had great application monitoring for .NET, and now we're actually introducing a whole bunch more of application performance monitoring for Java as well. Hey, guess what? Didn't we just announce something with Oracle and Java today? That's interesting. Also, we, of course, have System Center Management Pack for Windows Azure. So again, you want to be able to run your services where it makes business sense for you. It could be on premises in your private cloud, it could be in a service provider, or it could be in the public cloud on Azure. Wherever it resides is your choice. That's your business decision. We want to give you the best abilities, the best tools to do all of that. So for example, System Center Management Pack for Windows Azure. In addition, don't forget, we also have System Center Advisor, System Center Global Service Monitor, which is, again, building on this huge investment we have System Center and doing more of it starting in the cloud and integrating it in terms of System Center on-premise. And of course, don't forget, this all ties back into Visual Studio, the best platform out there for developing apps. So with that in mind, I'd like to invite Simon Perriman up to talk about application performance monitoring. Simon?
Thanks, Jeff. Hi, everybody. I'm here today to show you how you can extend your own testing infrastructure to take advantage of Microsoft's data centers worldwide. Now, being that I come from Seattle, I am, of course, selling coffee. Now, what's interesting about the Seattle coffee economy? We have three big companies up there. They actually have a value of about $50 billion. These three companies. So I want to go get a piece of that. Now, to kind of put that in context, that's higher than the annual gross domestic product of over 125 countries in the world. So great opportunity for me to come in as Seattle's fourth coffee company. Now, as I want to expand worldwide, I'm going to be selling to customers all around the world, but I'm based in Seattle. My developers are based in Seattle, and so I don't really know how well my website is performing for people based in Spain, Brazil, Japan. I don't have the luxury of having these testers worldwide giving me feedback. In fact, often, if a customer from Japan has a bad experience the first time they order from me, they may never come back. So I really want to make sure that I can ensure that my applications are performing great no matter where my end customers are. Now, we do this using System Center 2012 Operations Manager, specifically a feature called Global Service Monitor. Now, setting it up is relatively quick because it gives me the ability to test my own website using my custom tests. And what I mean by custom tests, these are actually tests that are written in Visual Studio by my developers to test my applications. And we get to test these from 16 different locations around the world. Now, you can see there's all different types of tests that we can run against all different types of application platforms. Setting this up is pretty straightforward. It asks you, what type of application are you running? Where do you want to test it from? What test do you want to use? What is the website that we are going to test? And then it asks us what type of performance threshold do we want? And what I mean by that is, what is a good end user experience and what is not quite good enough? Now, I want to clarify this point. we're not just testing application availability, whether the website works or not. We're actually testing application performance to see how well it works. Now, I'm going to cancel out the wizard here and actually show you some of the tests that we set up before. Now, this is my worldview. These are the 16 different points of presence that are actively testing my website based in Seattle. Now, you can see I got pretty good coverage from the United States, from Europe, but I'm kind of running into some challenges from East Asia and from South America. So it looks like my developers are going to be staying up late tonight trying to fix these problems, hopefully drinking a lot of my coffee. Now, what we really want to do is not just provide this information saying, hey, there's some challenges here, but provide some insight for our developers on how to go and fix these issues. If I go back into Operations Manager, I'm going to go take a look at my monitoring dashboard, and I can see some of these alerts. And we can see that we've got some challenges. They've surpassed this performance threshold that I've set. Now, if I take a look at this first alert here, it's going to give me some information. I'm going to log in. And it's going to give me this application diagnostics and tell me exactly how long it's taken to load these different websites. Now, I set a performance threshold of 5 seconds. This means when my customer submits an order, I want them to get a response, positive feedback, within this certain amount of time. But it's taken me almost 11 seconds to get the first bit. Another second or so to have the document object model ready, and then a little longer for the page to be fully ready. So this isn't quite good enough. This doesn't quite meet my performance goals that I'm looking for. But I want to get some additional information to send this over to my developer. Essentially, my goal here is to reduce the time to resolution with our developers, add some agility into the data center, and ultimately get this bug fixed faster. Now, as I go take a look at the second alert, it gives me the actual stack traces. It tells me where my performance overheads are, what code paths are being executed. Now, as the infrastructure guy, I'm just going to go send this over to my developer, have them analyze it. But this is going to save you time because you're no longer running these traces yourself. You're no longer collecting this information yourself. All of this gets captured for you automatically. Assigning it to a developer, it's as simple as changing our alert status, assign it to engineering, and click Apply. And what this will actually do is integrate with Team Foundation Server 2012, assign a brand new bug to that developer, so when they come in the morning, they get that detailed information of exactly what the problem was and information how to fix it. Ultimately, our goal here is just to simplify this experience for our developers, to make happier developers, happier customers, and ultimately provide you with a better service. Thank you.
Great, thanks, Simon. It's time. You know, a few years ago, the cloud was really, the cloud experience was similar to my plug-and-play, or my lack of plug-and-play experience with that CD-ROM. Bent paper clips, lots of tears, lots of hurt feelings. That's behind us. Now the cloud, you have this cloud plug-and-play vision, and we have implemented enough of that cloud plug-and-play vision with integrated technologies from Windows Server, System Center, and Azure that everyone in this room can succeed in adopting the cloud and taking advantage of its great power and agility and economics. So go out there and do that. Now, we got a lot of great sessions here this week. I encourage you to go to them. Yeah? Here's a few that you might want to go to. We will be at the Ask the Experts Hall, and I encourage you to fill out the session evaluations. We do read all of those. We read all the comments. Please do, if you liked it, fill it all out. I will point one thing out. Given that this is the first session of the conference, by definition, it is the best one you've seen so far. So feel free to point that out. And have a great TechEd. Thanks so much.
Thank you very much.